Similar manner, we are going to see what is a mole. A mole is the amount of substance which contains the same number of unit as the number of atoms in 12 grams of carbon, that is isotope of carbon, carbon 12. The mole is the basic unit of the amount of substance or the number, just it was present in dozen or gross. Now a mole is just a collection of 6.023 into 10 raised to 23 particles. It can be an atom, it can be a molecule, or it can be ion, any basic unit. This number 6.023 into 10 raised to 23, also known as Goodras number, represented by Na or L. The value of Na will be 6.023 into 10 raised to 23. Goodras number is nothing else but the number of atoms present in 12 grams of carbon 12. Goodras number is the number of elementary units, that is atom, molecules, ions in 1 mole of a substance. Let's take an example and understand. When I say 1 mole of oxygen atom, it means it contains 6.023 into 10 raised to 23 atoms of oxygen. The gram atomic mass of oxygen is 16 grams. That means 16 grams is equivalent to 1 mole, and 1 mole equal to 6.023 into 10 raised to 23 atoms of oxygen. Similar manner, if I take 1 mole of calcium, that means 1 mole of calcium is equivalent to 6.023 into 10 raised to 23 atoms of calcium. The gram atomic mass of calcium is 40 grams. That means 40 grams is equivalent to 1 mole, which is equivalent to 6.023 into 10 raised to 23 atoms of calcium. Similar manner, if I take 1 mole and see the relation between gram molecular weight, volume at STP, and the number of molecules and the number of atoms present in it. Let's understand the relation between these properties by taking few examples. To begin with it, let's take 1 mole of carbon dioxide molecule. Now carbon dioxide molecule contains 1 carbon and 2 oxygen. But now we have taken 1 mole of it. So 1 mole of carbon dioxide will be equal to how many molecules? 6.023 into 10 raised to 23 molecules of carbon dioxide. This many molecules will always occupy 22.4 liters of this gas at STP, and in this there are total 6.023 into 10 raised to 23 molecules. But how many atoms of carbon? Now in 1 molecule of carbon dioxide we have only 1 carbon. Similar manner, in 6.023 into 10 raised to 23 molecules, how many carbon will be there? It will be 1 into 6.023 into 10 raised to 23 atoms of carbon. What about oxygen? In 1 molecule of oxygen, it was 2 atoms, right? So, if there is 6.023 into 10 raised to 23 molecules, how many oxygen atom will be there? Right, it is 2 into our Goodras number, that is 2 into 6.023 into 10 raised to 23. What will be the gram molecular mass of this molecule? Let's take it out. CO2 is made up of 1 carbon, C plus O, carbon weight 12, oxygen 16, another oxygen also 16, so add the weight. So it comes out to be 44 grams. That means 1 mole of carbon dioxide is equal to 44 grams. 44 grams will always have 6.023 into 10 raised to 23 molecules, which will always occupy 22.4 liters at STP, that is standard temperature and pressure. Similar manner, we can take another example of ammonia. Ammonia gram molecular weight will be, for 1 mole it will be 17 grams. Now you know how to calculate it. It will occupy 22.4 liters and number of molecules present in it will be 6.023 into 10 raised to 23 molecules of ammonia. But how many atoms of nitrogen? 1 into 6.023 into 10 raised to 23. Whereas how many atoms of hydrogen? 3 into 6.023 into 10 raised to 23 atoms of hydrogen. If I take sulfuric acid, the formula for which is H2SO4. If I take 1 mole of sulfuric acid, how much will be the gram molecular weight? Add the weight, you will get 98 grams. Now this 98 grams will contain how many molecules? 6.023 into 10 raised to 23 molecules of sulfuric acid. But how many atoms of hydrogen? Since one molecule has 2 hydrogen atoms, so it will be 2 into our Goodras number. That is 2 into 6.023 into 10 raised to 23 atoms of hydrogen. How many of sulfur? 1 into 6.023 into 10 raised to 23. What about oxygen? It will be 4 into 6.023 into 10 raised to 23. Similar manner, if we take a compound barium chloride, that is BaCl2, an ionic compound, its weight will be, its gram molecular weight will be, if I take it for 1 mole, add the weight, you will get 208 grams. Now this 208 grams contains how many molecules? It contains 6.023 into 10 raised to 23 molecules of barium chloride, that is BaCl2. But how many ions of barium? That is Ba2 plus. It will be 1 into 6.023 into 10 raised to 23. Whereas how many ions of chloride? It will be 2 into 6.023 into 10 raised to 23 ions. Now let's see the application of this Goodras law. It has 5 major applications, and they are: first, to determine the atomicity of the gas. Second, it determines the molecular formula of a gas. Thirdly, it determines the relation between molecular weight and vapor density. Fourthly, it explains Gaylussacs law. And lastly, it determines the relationship between gram molecular weight and gram molecular volume. Let's take one by one. To begin with it, let's see how it determines the atomicity of a gas. What is atomicity? It is the number of atoms present in one molecule of that element. For example, monoatomic elements which contain only one atom in the molecule, example helium, neon, etc. Diatomic elements are those elements which have two atoms in it, example hydrogen, oxygen, chlorine. Let's see the application in determining the atomicity of nitrogen. It has been observed that one volume of nitrogen reacts with one volume of oxygen to produce two volume of nitric oxide. Nitrogen plus oxygen giving you nitric oxide, that is N2 plus O2 giving us 2NO. Let's take one volume of nitrogen combining with one volume of oxygen giving us two volume of nitric oxide according to Gaylussacs Law. Now by our Goodras Law, since the volumes are same, they should have the same number of molecules. So if I take one molecule of nitrogen combining with one molecule of oxygen, it should give me two molecules of nitric oxide. An atom is indivisible, therefore let's consider half molecule of it. In case of half molecule of oxygen, it will give us one molecule of nitric oxide. So half molecules of nitrogen is one atom of nitrogen. Similar manner, half molecule of oxygen is one atom of oxygen. They will combine together to give us two atoms of nitric oxide. Therefore, one molecule of nitrogen contains two atoms of nitrogen. Conclusion: a molecule of nitrogen contains two atoms. Therefore, it is diatomic. It can be also used in determining the molecular formula of a gas. Molecular formula, a chemical formula which gives the actual or exact number of atoms of the elements present in one molecule of that compound. For example, it has been observed experimentally that one volume of hydrogen will react with one volume of chlorine to give us two volume of HCl. So hydrogen plus chlorine giving you hydrogen chloride. According to Gaylussacs Law, one volume of hydrogen combining with one volume of chlorine will give you two volume of HCl. By our Goodras Law, one molecule of hydrogen combines with one molecule of chlorine giving you two molecules of HCl, that is hydrogen chloride. If I take 2 into 1 atom of hydrogen, it will combine with 2 into 1 atom of chlorine, whereas it will give you 2 molecules of hydrogen chloride. Therefore, a molecule of hydrogen and chlorine contains 2 atoms and therefore diatomic. 1 atom of hydrogen combines with 1 atom of chlorine to give you 1 molecule of hydrogen chloride. Therefore, the conclusion which you can draw is the molecular formula of hydrogen chloride is HCl. Now let's see the application of our Goodras Law in finding out the relation between molecular weight and vapor density. First and foremost thing, what is molecular weight? It is the ratio of weight of one molecule of a substance to the weight of one atom of hydrogen. That is, molecular weight, which is also known as relative molecular mass, is equal to the ratio of mass of one molecule of a substance to the mass of one atom of hydrogen. What is vapor density then? Vapor density is the ratio of the mass of certain volume of a gas to the mass of same volume of hydrogen, that is volume measured under the same condition of temperature and pressure, that is STP condition. So how do we take out vapor density of a gas? It is equal to the ratio of mass of a certain volume of a gas or vapors upon the mass of same volume of hydrogen. Let's see the relation between molecular weight and vapor density. Just now we have seen about vapor density. It was the ratio of mass of certain volume of a gas or vapors upon mass of same volume of hydrogen. Now, according to Avogadro's, we can replace the volume by the number of molecules, provided the volumes are same. Now, in this case, the volumes are same. That is the volume of the gas as well as hydrogen. Both the volumes are same. So, we replace it by molecules. So, vapor density will become a mass of one molecule of a gas upon mass of one molecule of hydrogen. But as we know, mass of one molecule of hydrogen is nothing else but mass of two atoms of hydrogen. So replacing the mass of one molecule of hydrogen by the mass of two atoms of hydrogen, we get vapor density is equal to mass of one molecule of a gas or vapors upon mass of two atoms of hydrogen. Now multiplying both the side by 2, so we will get 2 into vapor density is equal to mass of one molecule of any gas upon mass of one atom of hydrogen. But this is nothing else but molecular weight. So twice the vapor density, that is 2 into vapor density, is equal to molecular weight, that is RMM, relative molecular mass. So what conclusion we have drawn from here? That is relative molecular mass of a gas or vapors is always twice its vapor density. Now let's see with respect to explanation of Gaylussacs law of combining volume on the basis of Avogadro's law. Consider the formation of two volumes of hydrogen chloride from one volume of hydrogen and one volume of chlorine. Hydrogen plus chlorine giving you hydrogen chloride. One volume of hydrogen combining with one volume of chlorine giving us two volume of hydrogen chloride by Gaylussacs law. If I take n molecules of hydrogen combining with n molecules of chlorine giving us 2n molecules of hydrogen chloride by Avogadro's law. So one volume is equal to n molecules. Now if I take two atoms of hydrogen with two atoms of chlorine, it will give me two molecules of hydrogen chloride, that is hydrogen, chlorine, both are diatomic and one molecule is equal to two atoms. Therefore, one molecule of hydrogen chloride is formed from one atom of hydrogen and one atom of chlorine. Conclusion: thus Avogadro's law says that equal volume of gases under the same condition of temperature and pressure contains the same number of molecules. Explains the Gaylussacs law of combining volumes. Let's see the application of Avogadro's law in determining the relationship between gram molecular mass and gram molecular volume. What is gram molecular mass? It is the relative molecular mass of a substance expressed in grams, which is also called gram molecule of that element. Gram molecular volume is the volume occupied by 1 gram molecular weight of a gas at STP. The relation between them is the gram molecular weight, that is 1 mole of any gas, will occupy 1 gram molecular volume, that is molar volume, which is equal to 22.4 liters at STP. According to Avogadro's law, equal volume of all gases under the same conditions of temperature and pressure contains the same number of molecules. So, therefore, equal number of molecules of different gases under the same condition of temperature and pressure will occupy equal volume, but one molecule of a gas will contain 6.023 into 10 raised to 23 molecules, which is occupying the same volume at STP as 1 mole of any other gas. That same volume is the molar volume of the gas. How do we calculate the molar volume? That is gram molecular volume. It is equal to the ratio of gram molecular weight divided by weight per liter of the gas at STP. Say for example, if I want to find out molecular volume of oxygen, oxygen molecular weight is 32 divided by 1.429 grams per liter. That will give me molar volume. Whereas molar volume of hydrogen will be 2.016, that is molecular weight, divided by 0.09 grams per liter. And in both the cases, the answer comes out to be 22.4 liters. So what conclusion we have drawn? That gram molecular weight will always occupy 22.4 liters at STP. So if I want to find out gram atom, what is the relation of it and how do we calculate it? It is equal to mass in grams of an element divided by the relative atomic mass. If I want gram molecule, it is equal to mass in grams of the substance divided by relative molecular mass. So the relation at STP will be 1 mole will always corresponds to gram molecular weight, and gram molecular weight will always occupy 22.4 liters or 22400 cc, which is also equal to 6.023 into 10 raised to 23 particles. It can be molecules, ions or atoms.